Alright, hello again. Previously, we did some natural logarithmic equations like these. How about the problems like these? We now have some non-trivial denominators to work with, and consequently, maybe a bit bigger font? Well, maybe not. Maybe unnecessary, but yeah, let's go with that anyway. So here's the problem. Oops. And then let's put some space in between. Alright, how do you solve it? Well, step 1 is denominator, so flip this denominator to the other side by multiplying it away. Then you're going to get log of 2x plus 3 equals 2 times log of 3x plus 2. That's what you're going to get after flipping this denominator to the other side. Multiply the same thing to both left-hand side and right-hand side. Here, that'll just kill up this denominator down there. Come on. And then here, well, I have this right-hand side. Okay, that's why I said bigger font was not really necessary. We don't really need it because from this point on, we don't have denominators to work with. Well, let's go ahead and complete it. Log of 2x plus 3 is equal to log of 3x plus 2 to the second power now, after removing this over there. And then we can remove logarithm because there's nothing in between, so we can take exponential of this, exponential of that. I mean, basically this. So basically, exponential of this, exponential of that. I took the same thing to both left-hand side and right-hand side, so that's okay. And then log and exponential cancel out, log and exponential cancel out. Please note that I can't do that right away here because of this 2. There's an obstruction, so if I try to do this, this 2 works as an obstruction, so I cannot do any kind of simplification here. So as a result, 2x plus 3 is equal to 3x plus 2 squared, and what do we have? We have a quadratic equation to solve, but the right hand side is a complete square, so it's going to be a bit of an effort to break all these up. So 9x squared plus 12x plus 4, is that right? I just use complete square formula, but if you FOIL it and simplify, you're going to get the same thing. In the end, 9x squared plus 10x and then plus 1 equal to 0. Did I do this right? Flipping everything to the right hand side. Stop the playback and check the computation. And is that what you're getting? 9x plus 1, x plus 1. X is negative 1/9 from the first problem. I mean from the first factor. X equals to negative 1 from the second factor. Let's see, do they work? Plug in x equals to negative 1/9 here. 1/9, negative 2/9 plus 3. Looks like it is positive. Looks like it is positive, so looks like this one is okay. Looks like this is legitimate. Now plug in x equals to negative 1. How about this one, which I'm expressing as green? Plug into numerator negative 2 plus 3, that's positive, all right. Plug into denominator, negative 3 plus 2, oh, that's negative, so this one doesn't work. So this one doesn't work. This one works. So what do I have here? Okay, denominator, and then, all right, and plug in check. For negative 1, 9, okay. For negative 1, no. How about this one? Well, it's going to be pretty much the same. Flip the denominator to the other side. And then 1 times something, so I don't have to change. So that's what you get. You don't really need bigger font because I don't have denominator in except the very first problem. Okay, and then we have to get this one straightened out. 1 plus log of x minus 2 squared equals 1 plus log of 2x plus 11. But then again, this 1 plus, that 1 plus, we don't need these. We can simplify those out. So that's what we have. All good? And then what do you do next? Exponential of this, exponential of that, and we just kill off this logarithms in this highlighted part. Let's do this again. Exponential, and then exponential. We took the exponential of both left-hand side and right-hand side of this highlighted equation, and that'll kill up this logarithm, normal logarithm. And you get x minus 2 squared is equal to 2x plus 11. Do you see that? So that's the conclusion. X minus 2 squared is equal to 2x plus 11. And this one goes x squared minus 4x plus 4 if you FOIL it out. Please check the computation. And then flip everything to the left-hand side. X squared minus 6x minus 9. Is that right? 11 minus 4 negative. No. 7. 11 minus 4 is 7. Okay, all right. And then we can go ahead to factor. This is monic, so it's going to be easy. So we have x equal to 7, there goes 1. X equal to negative 1, there goes the other. Let's see, x equal to 7 will probably work. I just highlighted in blue. And this one, I don't think that's going to work. Let's check. Plug in 7. 7 minus 2 is positive. 7 times 2, 14 plus 11. Okay, all good. If I plug in x equal to negative 1 there, negative 1 minus 2, that's not going to work. We cannot have negative 3 inside the logarithm. So this one is extraneous. And then you have to stick with x equal to 7 only. Now, what if you forget the extraneous solution at the very end? Well, you're going to lose a credit or two. 9 out of 10, or at worst 8 out of 10. That's not too bad. The main part is getting these logarithms and then killing off that logarithm. That's the main part. After that, some algebraic manipulation regarding quadratic equations. Well, by now, everybody should be comfortable with all those. Okay, so much for natural, exponential, and logarithmic problems. And arbitrary based problems are going to be optional problems. The standard topics end here.